Hello the internet and welcome back to my channel. Today we have a motherboard. It's an ASK ATX55C motherboard. It's a pretty unknown one. I really struggled to find much information about it. And I'm shooting this video after this project, so I can anticipate you that this board has not one, not two, not three, but 4 different faults. And you'll see me almost waving a white flag until, well, I've already said too much. I don't want to spoil the video for you. Now, before we move on to the motherboard, I just want to say a couple of words about this. Just last week, the channel reached 1,000 subscribers. I'm incredibly excited and incredibly humbled by this. I just wanted to say thank you to each one of you for your views, for your comments, for your feedback, for supporting me. It's incredibly important. I hope to be able to create much more content in the future, and hopefully you're going to be with me and enjoy it on this channel. But enough with the digression, let's move on with the motherboard. Now, it doesn't look to be anything special. It's the usual socket 7 motherboard. It's an Intel 430TX chipset, which is, I guess, is nice. It has the usual IDE, serial ports, printer ports, some USBs, dual power supplies, dual memories. There's some cache here. Nothing worth mentioning, to be honest. Now, the motherboard has been kind of abused a bit. You can see from these capacitors here that probably the motherboard has been stored on top of other boards, and the other boards have been like scraping and damaging these capacitors. I see there is, I think this is a MOSFET. It looks like it's been desoldered here. I don't see any activity on the legs, even on the other side, so I'm not sure why that happened. Now, the most important thing of this board is I am unable to find a user manual or jumper settings or anything. Now, if you look here on the retro web, there is a page about the ATX55. Now, this is an ATX55C. I'm assuming, hopefully they're pretty similar, but the thing is, there's really nothing here on the documentation. There is only a mention about a post string and no more than that. I mean, there is a date here and that's it. Unfortunately, there's no other description or anything. So the problem is, before I can fit a CPU in this thing, I need to know how to set the voltage, most importantly, and then also obviously all the frequencies. Now, thankfully the board has some help, but not much. Now here I can see the multiplier setting. So that's for JP3839, JP40. So I know how to set the multiplier. And there is a mention here about jumper 3537, whether it's a dual voltage or single voltage CPU. Now, this chip here is the voltage controller for CPU cores, basically, and is controlled by these jumpers here. Now, unfortunately, there's no mention on how to set these jumpers. I have removed the jumpers to test a bit, and there's no information on the board about these jumpers here. So I need to figure out how these jumpers work for the voltage. This little chip here, it's an LX1662C. I think so, C0, CD. And here we are, this is a single chip programmable PWM controller with 5-bit DAC. We have all the schematics and everything. And as you can see here, the chip is controlled by, it's a 5-bit controller, so meaning that basically it has a 5-bit input, which is basically jumpers, connected to VID 0 to 4. And if I scroll down, I can actually find the table where basically based on whether the jumpers are open or closed, I have the output voltage from 1.34 volts to 3.54 volts. So looking here at the schematics, I can see the jumper is supposed to be connected from pin 4 to pin 8. So let's set up the tester, the multimeter, and see where they're going, where these jumpers are going. Okay, I have the meter in continuity mode. You can see here that's the pin 1 because I have a little dot here. So let's touch pin 4, 1, 2, 3, 4, and let's check whether this is going on this jumper here. It is. So then pin 5 should go to the next one. Yeah, pin 6 is the next one. Pin 7 is the next one, and pin 8 is the next one. Perfect, amazing. Now my CPU is an Intel 90 MHz, if I'm not mistaken, and it needs 3.3 volts. So looking at this chart here for nominal output, 3.3 volt But this is what it needs. We have to go from pin, that's VID 0, so that would be my pin 4, the first jumper on the left. So it needs to be basically open, close, open, open, close. There you go. So that should give me 3.3 volts. So I've got the power supply connected here, is my old small AT power supply. Let's power it up and see if we get anything and what we're getting. 3, 2, 1, go. There we go, 3.3. Perfect, that's amazing. Right, I guess this is time for the oscilloscope to find out what's the base frequency that's being sent to the chip. So let's power it up and see what we get. 3, 2, 1, go. Ah, there it is, 66 megahertz. This little chip here, which is ASK ATX55C, if I'm Googling it, I ended up onto this page. Unfortunately, there's not much, there's no PDF. If I try and download the PDF, it's not available anymore. But it says clock generator for Pentium-based design. So I'm assuming that these two jumpers are the ones I'm looking for, and I guess I should probably tinker with them. I mean, there are not many combinations here, and to be honest, there are not many frequencies that this board can support. So I would say I'll just take note that I get 66 megahertz when JP, that's a bit weird, 41 and 27. Anyways, when JP 41 and 27 are in position 1, 2. So as a start, let's move 41, 2, 2, 3. That's 3, 2, 1, let's power it up. 75 megahertz. Okay. Let's move JP27, 2, 2, 3. 3, 2, 1, go. That is 55 megahertz. And finally, I think I have JP41 to 1, 2, but JP27, 2, 2, 3. I'm looking for 60. I need to find my 60. 3, 2, 1, go. 60. Perfect. That's what I'm looking for. Fantastic. There we go. So we have our 55, 60, 66, 75. Okay, CPU is in, memory is in. I have an old ISA card. I have the buzzer in. I guess we can try and power it up. 3, 2, 1, go. Nothing. Okay, there's nothing on the diagnostic card, which implies that there's no operations being run by the processor. Right, now the CPU is in, we can check the actual voltage with the CPU in. Let's power it up now. No, voltage is correct. Okay, that's bad sign. Right, as this motherboard has basically it doesn't give any sign of life, I want to start my usual battery of tests. So the first one I want to do is to check the battery. It's probably not relevant, but I want to check it anyways. The battery is reading basically 3 volts, which it's kind of low, but I don't, again, it's totally, I guess, within specifications. So the battery is fine. Now, the next thing I would do would be to reseat the BIOS chip, but it's quite interesting that this board basically has the, how would you say that? The PCB is set for the, 32 legs standard chip, but then they replaced it, or basically, I mean, they adapted it for this different size, different package of chip. So obviously I can't reset this one. I'm not even sure how to reset it because I don't have the manual. I can only assume that these two jumpers here have something to do with it. So what I'm going to do, I'm going to move them to the other position, assuming this is the normal position, obviously, and see if anything changes. Actually, I would say let's try and power up the motherboard with these jumpers in this position, just in case, as another one that I've been working on, they had been left on the clear CMOS position by mistake. 3, 2, 1, go. Well, something's happening there. There's a 0, 0 rather than a dash, 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 dash. That's interesting. Since we're here, and now it's actually changed after a power cycle. So let's try the reset line. We can check on, I think it's this line here. Yes, it is working. The funny thing is, again, now it says 3F. And if I switch it off, and back on again. Now it's nothing. That's interesting. So let's try and put the jumpers back to the original position where we found them. And let's try again. And there's nothing. And if I reset, there's absolutely nothing. Now, next in line, we have the usual temperature check, and let's make sure that nothing is completely cold or very, very hot. Oh, wow. This is, oh gosh, I can't put my finger on it. Oof, okay, that's definitely shorted. And the whole board is actually warm in this place. What is this chip? Let's take a look. Okay, this chip here is an ASK ATX55C, and I found a data sheet online, and this is an I/O chip. It's definitely looking after these two serial ports here, but unfortunately also looks like it is looking after the keyboard as well. So I'm not sure whether this chip is required for the system to boot up. I would be a bit surprised. At least I would expect some kind of activity between the BIOS and the CPU, even if this chip is not working. Now, this chip is definitely shorted. What I'd like to do first is maybe make sure that the legs are all connected, and then I'll have to remove it and try the board without it. And if it still doesn't work, I guess I'll have to find a replacement. And no, this chip looks fine, again, at least when it comes to connections. Just out of curiosity, I have my thermal camera with me, and I'm going to power up the motherboard and inspect it under the thermal camera. So let's have a look. Yeah, you can see there is going up to 70 degrees, 80, 90, 100. If I'm inspecting the rest of the motherboards, well, no, this is much lower. That's actually the battery. The CPU obviously is getting warmer. We're talking about 30 something. That's 32 degrees, and it's probably something shiny. It is 180 degrees. Wow, this is melting down basically. Okay, let's switch it off. So at this stage, really, all I can do is remove that chip and try the board without it. Hopefully that's the one holding down the whole system and preventing any communications. Okay, I removed this little chip, and the first thing I want to try now is to power up the board again and see if anything has changed at all. I don't have the video card, I don't care. I'll take a look at the postcodes on the diagnostic board here. Right, let's power this up in 3, 2, 1, go. And still, I don't have any activity, unfortunately. And the hotspot has disappeared from this area, so the other chip is behaving. Again, nothing. I mean, the highest temperature here is 25 degrees. No, actually it's 44, but again, that's the residual heat from the preheating plate. We got rid of the silly hotspot. That's perfect, but now we are stuck again because I don't know what's wrong with this board. Now, while I was inspecting the board, I've noticed some potential damage here at the back. There's a big scratch here where these are pretty small traces, and I would say they're pretty important because they're close to the CPU. It doesn't look like it's damaged any traces here, to be honest, but the only way to know for sure would be to check with a microscope. So let's take a look. We have at least one broken trace, possibly two. You can see this one, but the next one, the following one, doesn't look very healthy. Everything else, because I'm not sure, for example, like this one, is there continuity like this one? It's hard to see. It might be okay, but it might not be. And the others seem to be okay. Not in great shape, but okay. I need to fix, well, definitely one trace, potentially two traces. I guess I'll have to check all the others. Okay, I fixed two traces, one with just some solder, one with a little segment of very fine copper wire. I'm kind of optimistic because those traces are actually going straight to the CPU, so I wouldn't be surprised if nothing works without even one of those traces disconnected. But the only way I have to know is to test it. So I've only connected the memory and the diagnostic board. We should see some kind of activity. If something happens, I should actually complain that the video card is not in. So let's give it a go. 3, 2, 1, go. Boo, still not working. Okay, so I guess I'd have to check those traces a bit more and maybe hopefully I can find something else which is not working. But there's a plot twist. So while I was troubleshooting the board, I realized the reset line stopped working. And I started thinking, well, maybe that chip I removed is actually responsible for the reset line. And I couldn't really understand from the datasheet. And at some point I realized that while the board was running with nothing happening, something was happening when I was touching these jumpers here, which are basically the voltage from the CPU. And suddenly, I started moving those jumpers, and look what happens now. Something's happening. The board is complaining, I think it's complaining of RAM, and my reset line works again. And it wasn't working a minute ago. But again, most importantly, some code is being executed. I'm actually noticing something interesting. These banks are labeled 0101. Do you think it's possible that I simply need to have like both zeros and both ones? Let me do a few tries and see what happens first. Again, let me try following the numbers on the PCB. So this is gonna be number 1, and this is the other number 1. This is weird, but let's try this. 3, 2, 1, go. Yes, it likes it. Look at that. It's trying to boot up, but it's not doing much. It's in a cycle. It should really beep because the video card is missing, but it's not beeping anymore, and it's resetting periodically. So let's stick a video card in it and see what happens. Right, video card is in, and let's see what happens now. Ooh, nothing. Wait a minute. Was working, was kind of trying, and reset line doesn't work anymore. So let me try and move these jumpers here. Maybe I'll put some contact cleaner as well. Now, as these jumpers are controlling the voltage, the V core of the CPU, let me check that I'm still getting 3.3 volts to the CPU. No, I'm getting 2.5, and that would probably explain why the board is not booting up anymore. So let's take a look. And I think I found that what the problem is. You see this jumper here? The pin is basically not engaged within the jumper. You see that? So I need to straighten the pin first. There you go. And hopefully now you can see that the pins are actually inside the jumper. So let's try again. So the board might try to boot up, but I want to check immediately the voltage just in case it's too high. 3, 2, 1, go. Oh, it's still 2.5. Okay, that's not great. Right, and it looks like this board is being through a battle. A war, actually, I would say. I've replaced this jumper, now I got 3.3 volts. That's probably why I was getting kind of intermittent different voltages. This was not making correct contact with the CPU. Okay, let's try this again. 3, 2, 1, go. 3.3, fine. And it's actually trying to boot up, even though it's still not complaining that the video card is not in. But at least it's doing something, and my reset line is working. You can see from the LED here. The board is stuck in a boot loop or booting loop, so I can see it's resetting every couple of seconds, and it's cycling through the same instructions over and over again. At this point, again, it doesn't really matter whether there's a video card or not. It does matter whether there's, for example, if I remove one module, the board complains. So it looks like the board is recognizing the memory modules. Now, either the board doesn't like my memory modules for whatever reason, or there's a fault, or I would say most likely the board is complaining that the I/O chip is missing. It could be that without that chip, the board just fails to initialize. Who knows? But I have a feeling I have to replace that chip first to see what happens. Now, unfortunately, I can find that chip on eBay. It's not very cheap. It's about £15. What is that now? Approximately $15. Not really the amount of money I want to spend on a board, which I don't even know whether it's going to work or not. But yeah, I guess that's probably the next step if you want to diagnose this board a bit more. Now, I was checking the legs of all the cache modules and everything. Everything looks to be fine, except this one. There's only one leg out of the whole motherboard. Everything is fine, but this leg. Amazing. There you go. Job done. After thinking about this issue for a while and also checking with the vogons.org community, thank you very much for your help, guys. It's literally a pleasure to be part of this community. I just wanted to try different RAM sticks. Now, these are SIM sticks, the 72-pin SIMS modules. I only have these ones, to be honest. They work on all my other motherboards, but it is very possible that this motherboard doesn't like this. Now, because I didn't have anything else, I went ahead and ordered a 168 16MB stick. I didn't have any of this, so it's nice to have to make sure, to test motherboards. So let's go ahead, plug this in and see if anything changes. Okay, ready to power up in 3, 2, 1, go. Right, so the motherboard is complaining basically there's no RAM. I can try the other slot. 3, 2, 1, go. Nope. Well, I know this sticks works because I tested on another motherboard. I guess there's one thing I can try. Now, I'm aware that these DIMM sticks come in 3.3 volts and 5 volts. On another motherboard, I have a selection switch for the voltage. Now, these sockets, if you look closely, they do say 3.3 volts. So, it should be the right voltage. But I guess it doesn't hurt to check whether we actually have 3.3 volts on these sockets. Motherboard is powered. I don't have the speaker connector, so we don't hear the horrible beep. The voltage here should be available on the 6th pin from the left-hand side on this small section here. So 1, 2, 3, 4, 5, 6. Oh well, 2.1, and it should be the same on this one. Okay, that's not what I'm expecting. I'm expecting 3.3 volts. 2.1 is just wrong. Okay, I've done a little testing off camera. What I think I understand is these two transistors here, I haven't checked, but I suspect these are MOSFETs. This is the switching mode power supply, let's call it that way. And with the inductor and the capacitors, this is a dual voltage motherboard. So that's the core voltage, which is selectable through these dip switches here. While this one it's a power transistor, which, if I'm seeing correctly, should provide the 3.3 volts for the I/O when in dual mode. And it also looks like this is providing the 3.3 volts for the memory modules and also some other chips. Let me show you what I found. So here I have my multimeter in continuity mode. If I see that right, this pin here of this transistor is the output of my voltage, and I can confirm it because I have continuity between the transistor and the memory module's supply pin. So this is going straight to the memory. But I also can see that this is going to this chip here, and I really can't find a data sheet or something. I can only find on Google a mention that this is the oscillator, and that makes sense because these two jumpers here are setting the frequency for the CPU. Also, I see that these two modules here, which are the cache modules, are also getting the same voltage. And again, I can't find a data sheet for this, but it says cache on it. And these are definitely the cache modules. So there's something wrong with that circuit there. So here's my circuit. Again, this is the power transistor I'm talking about. It's a D8A2-Y. It's a power transistor. I would say let's remove it and test it and see what happens. Okay, transistor is in my little tester here. Let's push the button and see what happens. Aha, 2 diodes. So again, that should be definitely seen as a transistor. So it looks like we found our problem, hopefully. And here I have the replacement transistor. The original transistor is a D8A2-Y. I couldn't really find this one online or even from China. I could only find a D8A2. It looks like the difference between the two models is the gain, the HFE. I don't really know whether that's going to change anything. Even Fauntleroy, my proper engineer consultant, is not sure about it. So what I'm going to do, I'm going to install the new transistor, but with the emitter leg lifted and connected to a load to check the voltage before it actually goes to the motherboard, to make sure it's actually as close as possible to 3.3 volts, just in case. Okay, here's my test setup. I have the emitter pin, or the emitter leg, not connected to the motherboard. I have an extension lead connected to it. The lead is going to this resistor, which is then going to the motherboard ground. And I have the multimeter connected to the emitter of the transistor to measure the voltage. So when I power the motherboard on, I should read more or less 3.3 volts. If I don't, then the transistor, or either there's another fault or the transistor is not the correct one. So let me power up the motherboard and let's see what happens. 3, 2, 1, go. Nope. 4 volts is definitely not right. Either this transistor is not good or there's another fault on the motherboard. I'd rather think that the transistor is not the correct one, to be honest. Right, while I'm sourcing the right component or think of what to do with that, I'd like to test this motherboard, see if it works. So I've decided to use my external power supply. It's fully floating. It means that it's not connected to ground. So my ground lead here is connected to the motherboard's ground. The positive lead is connected to where the transistor is supposed to output 3.3 volts. And as you can barely see, the power supply is set to 3.4 volts, and I'm going to test it now to see whether, that's just the last fault, and or maybe there's something else on this motherboard. So something weird has been happening, because when I first powered up the 3.3 supply, the board was drawing more than 2.5 amps, which felt a bit too much to me, and these two chips were getting really, really hot. So, I don't know, I thought it was a bit unlikely that both cache chips were shorted. So I've been checking with my thermal camera and everything, but they definitely looked shorted. I was reading at 3.2 volts here, because obviously the high amperage, the high current, and it was causing a voltage drop on the cable. And then I think what happened is I powered the main power supply first, and the 3.3 volts just half a second afterwards, and the board started drawing half an amp from the 3.3 supply voltage, and I could read 3.3 volts on the memory slot here. So everything seemed okay, even though this chip here is still getting like 60 degrees temperature. It's a bit weird. I'm not entirely sure what's happening here. What I'd like to try is to repopulate the board and see if by any chance it's doing anything this time. Okay, got CPU and memory in, so let's try and power it up as I did before, doing the main power supply first and half a second later the 3.3 supply voltage. Let's give it a go. 3, 2, 1, go. Still not doing anything. Let's check the voltage here. Well, we do have voltage at the RAM. This is getting stupidly hot. Oh my gosh. And this is not. So that's definitely shorted because it's way too hot. I can't believe how many bad components there are on this motherboard. How is that even possible? It's weird because now the board is actually drawing 600, 700 milliamp from the 3.3 supply. The chip is okay. It's getting lukewarm. Oh, wait. I didn't realize it's trying to boot up. Well, it's actually resetting like before, so the issue is still there. So it's not a memory issue. I'd like to show you this weird behavior of this board. So this is the power supply. 3.4 volts is the set voltage, 1.9 with all the dots there. That means it's my limiter. So it's limited to 1.9. Let's do 2 amps. So right now it's disconnected. Now if I power up the motherboard now it's reading 0.7 and the motherboard is actually trying to boot up, but it's resetting. If I power off and I power on again, it might take a few tries. I power up again now and it's doing the same. There will be at some point one attempt. when it actually skyrockets to 1.6 amp, and then it's when the chip gets really hot, real fast. That's a bit weird. Again, sometimes it boots up, sometimes, well, it's trying to boot up, and sometimes it just doesn't do anything. Sometimes it does that 1.6 amps and everything goes on fire. So I'm not sure, but it really feels that this chip is gone, to be honest. I might want to remove it, and again, hopefully the motherboard will still work and you will still see an external cache of half the size of whatever this is. Right, the hopefully faulty cast chip has been removed. I've wired everything back up. Remember, I'm still working on with the external power supply for the 3.3 supply voltage. I only have the diagnostic board. Let's power it up and see if there's any difference whatsoever. 3, 2, 1, go. But it's still doing the same. It's drawing 1.2 amps, which is a lot, to be honest. The cache module is getting stupidly hot. Okay, nope. One thing I've noticed is that the postcard last code before the motherboard resets itself is 05, and if I'm seeing this right in the Award World, which is the manufacturer of the BIOS of this board, that means the board is trying to initialize the keyboard controller. And that happens to be the keyboard controller. You might remember that I had to remove basically an extension of that chip, is this little chip which was here, which was burning hot. I'm just wondering whether the BIOS is trying to initialize this chip and the chip is complaining because this other chip is missing. I would say let's go ahead, let's replace this chip. You never know, that's the one which is stopping the board from booting up. I have replaced the chip and now it's time to power up. I'm still running on the 3.3 volt external power supply for the time being, so let's give it a go. 3, 2, 1, go. Whoa! Oh, that, what was that? Is it booting up? Okay. Let me power off this thing and plug a VGA cable. Right, let's try this again. Hopefully you can slightly see the monitor as well. 3, 2, 1, go. It's not restarting it. Woo! It's booted up! Look at that! Whoa! I wasn't expecting that. Honestly, I wasn't expecting that. Wow! Well, it's great because this board had so many faults. And I've been, spending quite a lot of time and a little bit of money, and it's so nice when you see it booting up again. I'm sure that some of you watching this video can understand my enthusiasm right now. This is live, I didn't test this before, so this is the first time I actually see this board running, or as someone would say, it freaking works. It's amazing, absolutely amazing. I love this. Well, the board seems to be working fine. One thing I'm noticing is that the board is reporting no cache memory. So obviously removing one chip has basically disabled the whole thing. Now, on different motherboards like this one, which is coming from the factory with only one chip, I see there's a little resistor here, which is connected between 1 and 2, and 2 and 3 is available. And I see the same setup on a Soyo motherboard I have. It looks like, I'm not sure, it's not really documented, at least I couldn't find anything, that this is to tell the system whether to look for one chip or maybe 2 chips. Now, unfortunately, this motherboard here doesn't seem to have anything, at least nothing I can see, which is obvious. If there is a way to disable one of the 2 chips, it's not obvious to me, and really, I don't know, I can't find a way. One of the last faults I have to sort out on this board is the 3.3 volts generation for the memory modules and the cache modules. Now, if you remembered, I tried a slightly different variation of this transistor, which was unfortunately producing the incorrect voltage because I was reading around 4 volts. However, when I tested it, I intentionally left the emitter leg disconnected from the board because I didn't want to risk injecting the wrong voltage on the board if the component was the incorrect one. So I assumed I had the wrong component and I moved on. However, this morning I tried some different transistors I had around here in the shop, and they were all giving me around 4 volts, and suddenly I realized, how is it possible that for such a simple circuit you need exactly a specific transistor? And I thought, well, maybe there is a feedback circuit on this board as well, and maybe the reason I was reading 4 volts is just the feedback wasn't working, because the voltage is not going back into the board. So the board is just saying, hey, I have no voltage here, so my feedback is obviously, it can't work. I've decided to do a slightly different test. This is one of these transistors I purchased, the same of this, the D8A2 without the Y, because I really can't find a Y. So this is exactly as I tested it before, and I know it does around 4 volts. The difference this time is I am also injecting 3.3 volts into the board through my bench power supply. And let me show you what happens, because I think this is totally fine for the board. Right, what I got here is my bench power supply. This is going into the motherboard. That one is the voltage out of the transistor which is on the bench. So it's driven by the motherboard, but the voltage is actually not going anywhere. I know it's a bit cumbersome, but basically the board will be driving that transistor based on the voltage which is coming through the bench power supply. So let me show what happens now. Let me power up this board. Power up in 3, 2, 1, go. You can see that now I have 3.33 volt fed into the motherboard, and my transistor is outputting 3.9, which is too high. But see what happens if I slowly move the voltage slightly higher, 48, 3.5. You see at 3.5, the voltage out of the transistor actually goes lower, and if I'm going over 3.5, it actually goes down to 2 point something. So the board is actually trying to regulate the transistor. So the reason why I was reading 4 volts is just the board didn't sense anything coming in, and it says, hey transistor, I need more voltage out of you. But unfortunately, I just left the transistor disconnected from the board, so I was only reading the transistor outputting as much as possible, which is probably around 4 volts, because I think it has an input of 5, so actually 4.8. So by the time you go through all the junctions and everything, I guess 4 volts is what is left. But it's working totally fine. I think there's nothing wrong with this transistor, it's totally fine. Right, transistor is back in place. I'm gonna test it straight away. So I got my multimeter on the emitter of the transistor, so we should read straight away the voltage. 3, 2, 1, go. Yep, 3.37. So that was fine from the very beginning, fair enough. There we go, the board is booting up, so the 3.3 volt line is fixed. Still no cache detected by the board, unfortunately. I wasn't really expecting anything different. Again, it's just the voltage. Well, that's good news. Well, I'm going to end the video here. I know the board is not fully working, the cache is still not working, but it looks like those cache chips are virtually unobtainable. I looked online a bit everywhere and I couldn't find anything, not even the data sheets. So I'm trying to source something similar. It will take a while. I have no idea whether it's gonna work. So I don't wanna consider this a part 1, because I have too many parts 1 on my channel, to be honest, so I don't need another one. And also I don't want to leave this project in a limbo for a while, because it will take a while before I can even get something. So the board is working. It's a cheap board after all, so I'm not really expecting much. Not much point in testing and benchmarking, obviously, without cache. But again, it's working and that's what matters, and I'm happy to wrap it up where we are. It was an interesting repair journey, at least from my point of view, which I totally enjoyed. We had 4 faults. We had the faulty serial buffer, which was part of the keyboard controller, preventing the motherboard from booting up. We had the faulty transistor for the 3.3 volts line. We had some broken traces at the bottom of the board, and we still have the cache not working, one of which was overheating, and probably the cause of the issue with the 3.3 line in the first place. I hope you enjoyed the journey as I did. Well, thanks for watching. Please hit the like button below if you like this video, and please also consider subscribing if you like what I'm doing on my channel. I hope to see you soon again on my channel. Meanwhile, as usual, you have a great day and goodbye.